Hello, I'm Dr. Martin Connors from Athabasca University, and we're visiting the Athabasca University Geospace Observatory. We do studies of auroras, and we also have a telescope here to take advantage of the very dark skies of Athabasca County. So this is a facility that many times has welcomed international visitors, mostly from Japan, although we've had people from the United States as well. It's used a lot in the winter. Right now it's the summer, so it's our down season. The nights are not very long. But because we often have visitors, and because in winter you don't want to be traveling between Athabasca and here, it's a half-an-hour drive, and in winter could be a bit hazardous. So we have 5 rooms here. So people can actually stay at the observatory, and there's a kitchen and washrooms, and so we have full living facilities here, often used by international visitors, and of course used a lot by me. So I'll come and show you just very rustic accommodation. This is one that's not made up. So basically, if you get here, you just are assigned a room, and you get a bed if you're lucky, because we have 3 nice beds, and graduate students or people like that get to sleep on futons. So this is one of the deluxe rooms. My wife compares it to a youth hostel. Bottom line is people come here to do scientific work. An interesting aspect, you'll notice that the windows are blocked, and so people come from Japan. They do not change time zones. So they do work at night, and then they sleep during the day with a blocked off window. We have a lot of collaborators in Japan, and we're connected by fiber optic cable. So they actually can, during office hours in Japan, operate their nighttime equipment here in real time from Japan. So that's a sample bedroom. This is a less fancy bedroom, but you probably don't need that. Just Japanese graduate students do what they're told. If they're told to sleep on that, they do. So when you first walk in, there's actually a drop-off area and workshop. So we've had an experiment going that requires really, really low noise. So we use batteries and we carry them out into the field, and so they come back here and get recharged. And then other than that, we have a little workshop here. Of course, the main workshop is back at the university. And then, as I mentioned, we have a full kitchen. So people can come, and as you can see, we can accommodate a group. Our legal fire limit is 9 people. So we have 5 bedrooms, so graduate students might end up sharing a room, and professors generally get the comfy beds. And then we have a very convivial time here. The Japanese often bring their own food and cook it and have a big sort of dinner party every day, so good fun. And for some reason, we've accumulated a huge amount of soy sauce. Okay, so this is the accommodations end of the building. And one interesting thing is, if you're cooking all that Japanese food and noodles and rice, it generates an awful lot of steam. And so what's very important to us is that the upstairs, which is where all the equipment is, and there are domes that may be at -40. So you don't want all that steam going upstairs. So we have 2 completely independent air circulation systems. One for where there are human beings and people cooking and even breathing is bad, and then a drier one upstairs. The air from the 2 of them has separate furnaces and circulates differently. And in the summer also we have air conditioning upstairs for our instruments. We don't have air conditioning downstairs. So let's go upstairs. We have red lights because red light affects the human eye less at night. So if you're working here at night, the red light doesn't affect you very much. So this light should turn on automatically. There we go. So again, we're in red light. So I should probably start off with our Athabasca University equipment that we're proud of. So this was from the Canada Foundation for Innovation, and it's maybe one of the most expensive cameras in Canada. So let's start off with that. So Canada Foundation for Innovation, and so this is what an auroral observing room looks like. As usual, everything is controlled by computer, nothing particularly special about the computer, and then there's a control box for the instrument there, but the instrument itself is in a dome. So these are clear plastic domes. They were actually made by the manufacturer of R2D2 and imported from England. And basically this is a camera that looks up when it's dark every night, photographs every night of the year, all sky view. So there's a lens on there that would be the envy of any photographer, and it's an f1 lens. And then you can see a sort of a tray there. So there are only very specific colors of light in the aurora. So the tray puts filters in place. It turns the filters on a cycle of about 1 minute. It goes through and takes all the different colors. And then we can put them together again to make a color picture, but often we just study the individual colors. There's red aurora, there's green aurora, and what our specialty here is blue aurora, and that's also called proton aurora. So red and green auroras are caused by electrons shooting down. So electrons are most of what we have in electric circuits in our houses, for example. But the proton auroras are actually caused by protons. So hydrogen is made up of a proton and an electron. And so they get split up in space, and often the electrons come down. And only in this region, in this latitude around the globe, and that's what makes this a very special place, do protons come down frequently. And so our specialty is the proton aurora. Our Japanese colleagues have a satellite up that has as one of its main missions to explore the proton aurora. So at certain times that satellite is connected to this region, and those are very special times for us to do the studies. By the way, the blue aurora itself, you might think, oh, this is exciting, I'm going to go out and see a blue aurora. The actual blue light is too faint for the human eye to see. You can sort of see them because you do tend to get the green light at the same time, and you can see that, but you can't actually see the blue light. So this is a very, very sensitive instrument, and so when it's using the blue filter, if you were to look through that with your eye, even though there is an aurora present, you would see absolutely nothing. So we'll move to the next room, where we also have a Canada Foundation for Innovation instrument that was developed by us and by the University of Calgary. So this one is pretty sensitive, but this one with its twin, which is in Saskatchewan, is the most sensitive instrument in the world for proton auroras. So there's an instrument rack, of course a computer. Computers control everything. And then if you look up, it actually looks pretty different than the other one. You can see there's a pentagonal box. I guess it looks sort of like a house with a roof on it. And in there are two what are called photo multiplier tubes. So unlike a CCD, which is in the other instrument, which is very similar to a camera, a modern camera, this just detects light from one region of the sky at a time. And so as a result, we also have, again, a little hard to see from down here, but up above that house, there's a mirror, and that mirror scans along the central line of the sky. And then we take a measurement, scan a little bit, take another measurement, and then we build up a picture of what it was like along a line on the sky. But each measurement is just taken at a spot. So this is called FESO, FESO. So what makes it very sensitive is that it's got very good background correction. So what that really means is that it isn't too obvious to the human eye, but for example, if the moon is out, the night sky is actually blue, much as the daytime sky. And these are blue proton auroras. So you have to be able to subtract the sky brightness off And that's what this instrument is very good at, because it has two photomultipliers. And in one of them, we just direct that exact light that's from the protons. And then in the other one, we direct two channels, but they go into one, of background noise. And then that can be subtracted off. So it makes it extremely sensitive. This is our Japanese room. And so this has a lot of equipment. We have a really strong collaboration with Japan. So a whole room full of equipment, and some of it is radio equipment. So we have a receiver out in our field, and again, these things have to be far away from everything because they're sensitive to noise, and so it's as far from the building as possible. And that antenna, the signal comes back to here, and then these computers digitize it. And actually, what they're recording is very much like sound. So the sampling is very fast, and then it's continuous. So we generate a lot of data here. And as I mentioned, we have fiber optic to send it out. If you look up in this dome, you'll see some things that now look sort of familiar. So there is one camera there that is very similar to ours, and you can see the tray on the front. It actually has a few more different filters than we have, and so there's good complementarity there. We also have on the right, you can see a sort of a blue filter. So that is a video camera taking real-time video of the aurora, so very fast. And for that you need a really, really sensitive camera because auroras are faint, and so that's what they have there, and then a filter in front. And then the green box is actually kind of a surprising thing. It was made in the 1990s or so, maybe even in the 80s in Japan. And what it does is actually looks at the details of the spectral lines that are made by the protons. And so from that you can tell their speed, you can tell how many of them there are. And it's been operating here continuously for a very long time. And the sad part is that it is custom built and uses this computer from Japan. And so this computer, if it ever goes down, you cannot replace it. Even the cards in it that control this device cannot be replaced. So we have sent it to Japan a couple of times for repairs. So they probably cannibalize their junk bin for stuff that goes in these computers and then send them back to us. Luckily, a product made in Japan in the 1980s or early 90s, very reliable, so that's good. This is just a controller for their camera. This is more controls of the fast camera up there that I showed you. So we'll go over to the next room and open the next door. So this is also a Japanese room in some senses, because these are all the Japanese boxes that the stuff came in. So it's only on loan, and in principle one of these days we have to send it back. So we kept the boxes. Everything is custom fitted, all delicate equipment. It goes in the boxes in a cradle, and so that's why we have to keep all these boxes. So we took some previous equipment out of here that was being used by our commercial partner, and we're dedicating this now to 3 separate instruments from the University of Calgary, and our commercial partner will be working in our dome room. So the Calgary install was supposed to happen in March. So you know what happened with that. We don't know when it will be installed. So when this is all over, we get some more nice equipment from the University of Calgary. That's for a project called T-REX, and that means Transition Region Explorer. So I was mentioning that we get these special proton auroras, and someplace further north, like Yellowknife, they will get more spectacular auroras than we do, but they're the ordinary auroras. We are in the transition region where you go from having ordinary types of auroras to things that happen at lower latitudes. So Transition Region Explorer is also interested in looking at such things. Soon this will be full, but right now that's what one of our domes looks like. We also have a different Japanese university. The instruments in there are mostly with Nagoya University, and this is from Tohoku University in northern Japan. Basically, this is a radio experiment. This is a radio receiver. They actually listen to man-made transmissions, and how much of them gets through tells you a lot about the conditions in the ionosphere above us. So we'll carry on. So things get less impressive as we go. So this is actually my astronomical experiments room, for now anyway. And basically this very unimpressive looking device, well, there's also a small auroral camera that was on test for the University of Calgary. But this device is actually a camera mounted up so that it could be used to photograph the skies at night. And so it's computer controllable where it points, and it can also track the stars. So it's completely homemade and actually works pretty well, but in the summer it does not get much use because it doesn't really get very dark. Let us skip a door because our computing hub is not quite along the same vein as this observing stuff. This goes up to our roof, but I'm not allowed to take you up there because it doesn't have any railings or anything, and if anybody falls off, the amount of paperwork to fill in would just be incredible, so we're not going up there. So this is, again, somewhat less impressive looking, but these are basically ordinary cameras that are photographing the aurora. We also have a light meter, so we've been measuring the darkness of the skies here. I'm pleased to report they are very dark. They stay very dark, so that it's not as if there's going to be a mall built down the road. So basically these are computer controlled, fairly ordinary cameras, although one of them is from Japan, a big one there that we're testing out. And that's a pretty impressive Sony Alpha camera with a pretty impressive lens. So that streams back to Japan. When it's nighttime here, it's daytime in Japan. So what the Japanese want to set up is real-time video of the auroras from here that people can then just watch as a podcast or something, but in real time. Unfortunately, right now we're in the bottom of the solar cycle, so there aren't really very many impressive auroras. Okay, so we will just go to our computer hub. There we go, here I am. So basically we have a lot of computer equipment here. All of the internet comes back to here and goes on racks to the various rooms by hardwired internet, and then goes to here and is put into fiber optic cable. So we had a specially laid fiber optic line to here, and so we have really high speed and very good, very reliable too, fiber optic link. We also have a relatively high power demand, quite a large number of circuits because there's just so much electrical stuff here to plug in. This actually looks like yet another box of computer stuff, but it's got a bit of an interesting history to it. There's a NASA project called Themis, and Themis has 5 satellites detecting conditions in space relevant to the aurora. And one of the brilliant ideas that they had, which involved the University of Calgary and then us as partners with them, was to photograph the auroras from below while Themis is up above. And that way you can see what happens in the aurora based on, for example, protons coming in, or more usually electrons. There was a good idea to have a network of cameras across Canada, and we have one of them, and it's up on the roof. There is actually a camera connected to that, and that cable goes and snakes up eventually onto the roof and controls that camera.